We're here to solve this easy as Japanese sums puzzle by Salih with an almost all triples theme. These two tens at the bottom are the only tens, but every other clue is there 3 times, which is a really elegant theme. And we've got some small values, like 4 is going to be 1 or 2 digits long, 5 is 1 or 2 digits long. I think the key place to start is with these 12s and 11s. 12 can be 3 or 4 numbers long, 5, 4, and 3, or 5, 4, 2, and 1. Those always take at least 3 cells. And so let's imagine we didn't take the third cell in from this direction, then we can't take the first 2 and get to 12, and then we're left with taking 15 altogether. So 3 in must be a number, must be a number, must be a number. Same works out for the 11. 11 is 5, 4, and 2, or 5, 3, 2, and 1, or either 4 on its own or 1 and 3 together are left out. And similar thinking, this cell, this cell, this cell can't actually be blacked off because those would cause issues, so they are filled in. That completes this set of 3 in a row. And this is probably an okay starting point for this puzzle. We'll know some things like we can't take both of these cells, so we could mark in, if I'm getting my notation right, one of these is shaded off at least, maybe both. But I think one of the key things to do is actually notate, like over here, this is a 1, 2, 3, and that should clue us into this kind of thinking. The big values, like a 12 always has 5 and 4 in it. 5 and 4 don't really want to be over in the space at all. And let's actually take that one step further. Like, can a 5 be here, here, here? Then it's interacting with these 4 clues. So all of these positions are bad for a 5. 11 requires a 5 in it. I think the first number I can place that gives me some confidence is a 5 right up top. That means I am going to take a value here. This being a 5 with a 1, 2, or 3 means I'm not getting the 5, 4, 2 sum. I'm getting a 4-digit sum. And I'm going to have a 1, 3 cell here. I now have to place a 4 in the bottom, and a 4 can't go in this cell because it has to be part of a 12 sum, so a 4 is in one of these. And that 4 looks like it's going to cause some issue pretty quickly if it's up top in this row here. Why is that? Well, notice it would quickly cancel the left and right. That means it cancels these. It means where 10 has to be at least 3 cells long, we're going to have to take cells out to here, and now this row needs to get to a sum of 4 in 3 cells. That's really, really broken. And so here's a case where just because of the constraints, 4 has to dodge the 4 clue. We now get the starting point in the grid, and let's still keep thinking about 5s and 4s. It was useful to do. Let's go to the first column. Can a 5 be here, 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 here? In all cases, no. 5 already in this row. The 12's eliminated for these 3 cells, and the 4 clues eliminated for these cells, so this is a 5. And that means we have to take at least 2 more cells. This 4 clue gives us as a 4, completes this as a 1. We no longer can take this straight away. We have a 2 and 3 to complete the top, and this cell can be a 3 only. Still can be useful, so we can't do more there. But we're now in a space where we know we've got to, because we've only got one more gap. This is a 1, 3, 4 cell. There's going to be an X across here, and all these are taken. Can I do more than that? I need to have a 2 down here, and then a gap. I think then that means these cells get taken, so that looks like the horizontal clues I can be using right now. Let's come to the vertical ones. I've not looked at this 5 set, but I can't have all of these in a row, and I can't have 5 on its own down here. So these 2 cells are going to be how the 5 adds together, and that cancels up here. This cell can't be a 5, and 1 and 2 are to the left, so this is a 3, 4, leaving behind a 1, 2. My guess is I can do even more than that if I keep working along these. So let's go to this third column. Let's come back to our favorite game of where are the 5s and the 4s, and let's start from the digit 5 again. So 5's not in the top. The 12 to the right cancel 5s in these cells. 5 is not here. 5 is not here. 5 doesn't want to be away from this 12 clue, so I've got just this spot for a 5. For a 10 to get to a valid sum, it's going to always have to take one more. That means this 2 does come in. That 2 is going to quickly cancel, and 5 and 2 is only left with the value 3 to take, so this cell right above has to be a 3, puts in this 1, puts in this 2, puts in this 3. Got these shaded cells. We can mark off these X's. It also says we have these shaded cells. We're getting a lot of progress doing this. Got a 1, 4 up top, and still thinking about where does the 4 go in this row. 4 doesn't want to be hidden from a 12 clue, and if it were over in these cells, it's not in that 12 clue, so this must be a 4. There's a 1 across these somewhere, and we'll want to think through that. in a second, but we also now know that this 4 over here has to get completed to the left because this cell is marked off. So this is a 3, this is a 1. We now have 2 and 3 on their own. So notice that this 2 will work with that 1 to be all the leftovers for a 12. This 3 on its own will work as the leftovers for that 12. So there are no more values on the left here, and there is just going to be an x alongside that 1. So 2 up here is finishing this column. That finishes this sum. Let me, get to that color. That means over here, this cell is now left to only be a 1, and we've got a 4, 5 coming down. This is a 4, 5 cell, this is a 4, 5 cell, this is a 4, 5 cell, so we're getting some good structure there. Can we do some more here? Well, this fourth column needs a sum of 5, and it's going to have to be using the bottom space because there are only 4 values down here. It can't be a 5 on its own, so it's got to take 2 cells, and with the 1 up above, or the 4s on the left, this is forced to be a 2, 3. That means what I'm placing in left over in the space is a 4, 5 with an unknown. Notice that this 2, 1 is going to cancel one of these cells, so this cell for sure is used, and then the remaining thinking is going to be tied to which of these can still be a 4, 5 cell. Again, 4, 5 is part of a 12 sum, so if this is the cell that's used, then all of these are part of that sum. That looks bad. This being used is okay as long as we shade these, mark this off, that pushes this down. So this is 1, 2, 3, canceling this. This gets shaded. We've got this kind of 4, 5 going across. We've got this is a 1, 2 cell. This cell can be marked off. This can't be a 4 or 5 because those are below, so this is a 3, this is 4, 5. That 11 wants to have the 5 within the sum, and it could be missing the 4, but needs 3 in a row to do that. 4 in a row to do that. So anyway, we do know that this is actually part of that sum. That can't be a 1 or 3 from the left, and the other values are bracketed here. This must be a 2. That cancels these, marks this in, cancels this. These are marked in as a 1, 3 set. This gets colored in. This will have to be part of a 4, 5 set. Can this be a 4, 5 on its own? We've got 1, 2, 3 cells up here, so we need to shade 2 down here at least. Can't be 5 on its own, so this has to be 4 with 1. Marking this off, marking this in. So this being 4, 1 gives me 3, 1, 3, 2, puts in this 2. This 4 gives me 5, 4, 5, 4, 5, 4, 5, 4. Still need a 5 in the space, it can only go in here. This cell is getting marked off. These getting marked in. This is a 2, 1, and 3, and the cell gets marked off, and we're through the grid. So very good challenge. I think the first key observation is seeing how the large sums work and where we've got to take some of these cells that are interior to the grid, but the main constraint is actually how these rightmost 12s and leftmost 4s really eliminate the options for 5s and 4s in the first, second, and third columns. And so we started with this top 5 that ended up giving me this bottom 5, giving me a 5 here, also forcing how these 4s went, and that gave a lot of headway into the middle of the grid. I think the last key insight was when we had these 3 cells left over for a 4, 5, and an x, and we could mark off this option because of how it'd be incompatible with the 12 sum to the right that needs to have a 4 and 5 within it. So a lot of great logic throughout, and hopefully this video helped anyone who got stuck in this puzzle. Thanks, Salih, for the construction, and we'll see you again soon.